You ever stop and think about what's really happening when you browse a website, shoot off an email, or grab a file? You're actually speaking secret languages. They're called application protocols, and they're the invisible rules that make our entire digital world go round. So in this explainer, we're going to pull back the curtain and decode how it all works, one protocol at a time.
So, here's the game plan. First, we'll demystify what these languages even are. Then we'll dive into the big ones you use every day, like browsing the web and sending emails. After that, we'll tackle the rules for moving files around, and we'll wrap it all up with the single most important security tip you need to know.
All right, let's start with the basics. Think of these protocols as the grammar of the internet. Seriously, without them, your computer and a web server would just be shouting digital nonsense at each other. It would be total chaos.
You know how it feels, right? It's all so seamless. You click a link, a page just pops up, you hit send on an email, and poof, it's gone. But underneath all of that smooth magic is this incredibly structured conversation, a super high-speed negotiation happening between machines. And this right here is the heart of it. An application protocol is just a specific set of rules for a specific job. It's not a one-size-fits-all deal. Nope. There's one language for web browsing, a completely different one for sending email, and another one for getting email. Every single task gets its own instruction manual. Okay, so let's zoom in on the protocol you probably use hundreds of times a day, maybe without even realizing it, web browsing. And more importantly, let's talk about how you can tell in an instant if you're safe or not.
Just look at this. It perfectly shows how much of a difference one little letter can make. On the left, you've got HTTP. That's the original. It's kind of like sending a postcard. Anyone who gets their hands on it along the way can read your message. But on the right, you've got HTTPS. That S stands for secure, and it changes everything. It's like putting that postcard inside a locked, armored box.
Now here's the crucial part. HTTPS takes you to the exact same website as HTTP. The only difference is how it gets you there. It wraps the entire connection in a secure, encrypted tunnel. This is what protects your passwords, your credit card numbers, all your sensitive info. And the easiest way to spot it, just look for that little padlock icon right next to the web address in your browser. If you see that lock, you're golden.
All right, let's switch gears to another thing we all do every day, sending email. It seems so simple, right? But sending a message is actually a whole journey, with different protocols handing off the message along the way like a relay race. So check this out. When you hit send, that's step one. Your email app uses SMTP, the Simple Mail Transfer Protocol, to push your email out the door to a mail server. Then, in step 2, SMTP is used again to shuttle that message from server to server until it reaches the right neighborhood. But for the last step, step 3, things change. The person receiving the email uses a totally different protocol, either IMAP or POP3, to pull that email down from their server so they can read it. Key takeaway, SMTP sends, IMAP and POP3 receive.
So you might be asking, why two different protocols for receiving mail? Well, think of POP3 as the old school way. It's like going to the post office. It downloads your mail onto your computer and usually deletes it from the server. It's simple, and it works great if you only ever use one device. But then there's IMAP. IMAP is modern. It's like a magical mailbox that lives in the cloud. It keeps everything synced. If you read an email on your phone, it shows up as read on your laptop. It's built for the way we all live today, bouncing between devices.
And hey, are you starting to see a pattern here? Just like with websites, security for email is absolutely critical. And you guessed it, each of these email protocols has a secure version. And they make it easy by just adding that magic letter S to the end. SMTPS, POP3S, and IMAPs. It's the exact same idea. Add a layer of encryption to keep your conversations private.
Okay, so we've covered browsing and email, but what about when you need to move really big files or even take control of another computer from far away? Well, you're probably ahead of me here. Yep, there's a whole family of protocols just for those jobs.
This table lays it out nicely. First, you've got the original FTP, File Transfer Protocol. It gets the job done, but it's not secure at all. Then you have two secure options. FTPS is basically FTP with that layer of encryption added on top. But SFTP is a bit of a curveball. It's not really FTP at all. It's a totally different protocol that runs inside a secure SSH tunnel. And that brings us to SSH itself, the secure shell, which is the absolute gold standard for securely logging into and controlling another computer. Seriously, if you remember nothing else from this explainer, remember this quote. The difference between secure and insecure is so often just one letter, S. HTTP becomes HTTPS.
FTP becomes FTPS. That S is your signal. It's your visual cue that your data is being protected.
Okay, let's bring it all home. What are the absolute core ideas you need to walk away with? This is the essential stuff, not just for passing an exam, but for staying safe out there in the real world.
Let's just run through the checklist. Number 1, always know the secure alternative. If you have a choice, pick the one with the S. Number 2, remember the flow of traffic. SMTP always sends things out. IMAP and POP3 retrieve things. And number 3, use the right tool for the job. If you're about to type in a password or a credit card number, you absolutely have to be on an HTTPS connection. No exceptions. So, if we had to boil all of this information down, past the acronyms and the details, to one single, simple, unbreakable rule for staying safe online, what would it be?
It's this. Just look for the S. That's it. Whether it's in the protocol name or it's that little padlock in your browser, that S is your best friend. It means secure, it means encrypted, it means someone's got your back.
So these protocols, they're not a secret language to you anymore. You now know the difference between sending a postcard for the whole world to read and sending a sealed, armored letter. The power to protect yourself is right there. So the only question is, will you use it?